For centuries, people have told stories to explain the moving lights in the night sky. The curtains of greenish-white light with a pink fringe. People describe this light as the breath of Jesus, powerful spirits, or angel light. An early 20th century explorer wrote about the bloody red and the ghostly green lights. These lights, of course, are the aurora borealis, the northern lights, and in the south, an aurora australian. Most of the time, they are greenish yellow, but sometimes they take colors from violet to red. The auroras can be seen at any time of the year with the right atmospheric conditions. They are most often seen near the north and south poles during time of maximum solar activity. The closer to the north or south pole you are, the better you can see the light. The auroras occur in the ionosphere. The ionosphere is a layer of the upper atmosphere where high-energy solar radiation strips electrons from oxygen and nitrogen atoms and leaves them as positively charged ions. The auroras are the result of a complex interaction between the solar wind and the Earth's magnetic field. Here's what happens. The sun's heat charges the particles in the solar wind. A stream of electrically charged subatomic particles that continually emanates from the sun. As the solar wind approaches Earth, it is deflected by Earth's magnetic field and diverted north and south towards the magnetic poles. The interaction between the solar wind and the magnetosphere generates beams of electrons. These electrons collide with atoms and molecules with the ionosphere near Earth's magnetic poles. The collisions rip apart molecules and excite atoms. Thus, oxygen and nitrogen atoms in the ionosphere become excited or ionized, or all the heaven or ionized atoms return to the normal state from their excited energized states. The ions combine with free electrons, and as they do so, they emit radiation. Part of this radiation is visual light. The aurora borealis and aurora australis. Yes, Simon. It's sign electricity. Yes, that's right. The auroras are an electrical phenomenon, as you know. An electrical generator has two components, a conductor and a magnetic field. To generate electricity, the conductor has to move across the field to produce a force. With auroras, the conductor is a solar wind carrying a stream of charged particles. So what happens is when the charged particles reach Earth's magnetic field, they move along in the field towards the north and south magnetic poles. Exactly. And then the particles collide with the gases in the atmosphere, oxygen and nitrogen. And the oxygen and nitrogen atoms get excited. And then, when the particles get de-excited and return to their normal states, they emit the auroras by releasing energy in the form of light. Oxygen releases either dark red or ghostly green. Nitrogen emits rosy pink or magenta. The activity of the auroras varies with the sun's activity. When the sun is quiet, the auroras can be seen only in small areas. When the sun is active, however, the aurora borealis can be seen across South Canada and the northern United States.